Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. My name is Dhian Pertiwi. I come from the Faculty of Agriculture, Sumatera Utara University. I want to say thank you to the moderator, Mrs. Ernie Johan, PhD, who has given me the time and opportunity to presentation my journal about yield traits of soybean mutant genotype based on high production and resistance to stem rot disease of Atalia rossi. Introduction. Soybean is the third most important food crop after rice and corn, which is rich protein to improve people nutrition. The very large demand for soybean and the limited ability to import, so it is necessary to develop domestic soybean immediately. One of the inhibitors that can reduce soybean production is stem rot disease. Stem rot disease by Atalia rossi is a potential disease in soybean because the infected plants will be die and the pathogen can long-lasting in the soil in the form of Sclerotia. In a humid environment, Atalia rossi also infect branches and leaves near the soil surface and can bridge the spread of mycelium growth to other plant parts. According to Wahyuningsi 2005, yield loss by stem rot disease can reach 30%. This loss often occurs on land that are always planted with soybeans and other legumes. The development program needs to be supported by plant breeding as an effort to overcome problems in the development of soybean cultivation technology. Improvement of soybean agronomic traits such as early maturity, high production, and tolerance for stem rot disease through mutation breeding is one of the alternatives. So, the use of disease-resistant varieties is a practical control method that can be preventive. The objective of the study was to determine the level of resistance and production of the 7 mutant genotype under condition of disease and optimum compared to the comparison and parent varieties. Material and method. Place and time of research. This research was carried out from March to August 2019 on the research land of the Faculty of Agriculture, Sumatera Utara University. The propagation isolate of Atalia rossi was carried out at the Laboratory of Plant Disease, Faculty of Agriculture, Sumatera Utara University. Research method. Soybean seeds becomes from putative the seeds of 7 mutant genotype is obtained from the selection of the 6 mutant generation. Yield test research used an augmented design. The treatment consists of 11 genotypes and 3 soybean varieties as comparison varieties or control. Control plants were endosperm varieties as a source of yielders, agromulyo, and kipas putih. The 3 comparison varieties were repeated 3 times, each consists of 30 plants, both of them at the experimental design. Data were analyzed using ANOVA. The further test is significantly different using Dannat and DMRT test with alpha 5% to compare means between each of treatment. Observation data consists of plant height, number of branch, flowering egg, harvest egg, number of pods, number of seeds, seed weight, and weight in 100 seeds. In addition, the observation data for the disease section consists of incubation period, disease incidence, disease attack intensity, and stress sensitivity index, which parameter data comes from seed weight. Research and discussion. In the table 1, about performance of soybean control varieties in optimum land show that the highest plant head character was found in the Andes Moro genotype is not significantly different with Kipas putih and significantly different with agromilio, which has the lowest yield. The highest number of pods was found in the Kipas putih genotype is not significantly different with Andes Moro and significantly different with agromilio, which has the lowest yield. The largest number of seeds was found in the Andes Moro genotype is not significantly different with agromilio and significantly different with Kipas putih, which has the lowest yield. The largest seed weight and weight 100 seed character were found in the Andes Moro genotype is not significantly different with agromilio and significantly different with Kipas putih, which have the lowest yield. In the table 2, about phenotypic performance of agronomic character of 7 mutant genotype soybean plants in optimum land show that 9 genotypes were significantly different from the 3 comparison varieties in the number of branches, number of seeds, and weight of seed. 3 genotypes were significantly different from the 3 comparison varieties and the character of the number of pods. 6 genotypes that were significantly different from the 3 comparison varieties on the character of weight 100 seed. And the 2 genotypes that were not significantly different from the parental variety Andes Moro on all observed characters. Of all genotype tests on each observation character show that the 3 best genotypes were M108-25 3/7, M211-32/3, and M200-12 6/5. The most advantage of them that they have a lower plant height, the higher number of seeds, and weight of 100 seeds than the parents and the 2 comparison varieties like Andes Moro and Kipas putih and other selected 7 mutant genotype soybean plant population. So, they can be recommended for yield testing with high number of seeds and weight of 100 seeds so that it can increase soybean yield potential for food needs. In Table 3, about performance of soybean control varieties in land infected by stem rot disease show that the highest flowering egg character was found in Kipas putih genotype is not significantly different with Andes Moro and significantly different with agromilio. The highest plant head character was found in the Andes Moro genotype is not significantly different with Kipas putih and significantly different with agromilio. The highest number of pods was found in Kipas putih genotype is not significantly different with Andes Moro and significantly different with agromilio. The largest number of seeds was found in the Andes Moro genotype is not significantly different with agrumulio and significantly different with kipas putih. The larger seed weight and 100 seeds character were found in the Anismurri genotype is not significantly different with agrumulio and significantly different with kipas putih. In Table 4, about phenotypic performance of agronomic character of 7 mutant genotype soybean plants in disease stress, show that 6 genotypes were significantly different from the comparison varieties in the number of branch and plant height. 3 genotypes were significantly different from the comparison varieties in the number of pods. 7 genotypes were significantly different from the 3 comparison varieties in the number of seeds and seed weight. 5 genotypes were significantly different from the 3 comparison varieties in weight 100 seed. 2 genotypes that were not significantly different from the parental variety and Gismora in number of pods, number of seeds, seed weight, and weight 100 seed character. Of all genotype tests, on each observation character showed that the 2 best genotypes were M100 at 25 3/7 and M200 at 12 6/5. The most authentic of them were that the number of seed weight, and weight of 100 seed were higher than the parents and the 2 comparison varieties, and the 7 mutant genotype soybean plant population are not infected by other selected diseases. In the Table 5 about incubation period of stem rot disease in soybean plants, so that incubation period of several soybean varieties is different. The varieties of Andesmoro and Agrumulio, genotype M100 at 25 2.7, M200 at 17 18/5, M200 at 17 13/6, M300 at 6 33/8, M300 at 8 35/7 show the fastest incubation period and the 5 after inoculation, while genotype M200 at 12 6/5, M200 at 25 3/7 had slower incubation period and the 12 after inoculation. In Table 6 about incidence of stem rot disease in soybean plant show that incidence of stem rot disease in soybean plants after Atelier was inoculated were carried out at 7, 10, 13, 16, 19, 22, 25, and 28 days after inoculation. Observation of this incidence was carried on brown spot at the base of the stem of Atelier, which is a symptom of stem rot disease in soybean plants. The highest percentage of disease incidence in the genotype M300 is 6 33/8, M300 AA 35/7 was 33.32%, and Angismoro variety was 93.33%. The lowest percentage of disease incidence was found in the M100A 25 3/7 and M200A 12 6/5, genotype of 25.57%. In Table 7 about disease attack intensity of stem rot disease in soybean plants show that cisgenotype and control variety kipas putih are classified as moderate to damage, with the range value about 28.7% until 40%. and two counter variety, Anismur and Agromolio, were classified as severely damaged with the range value about 41.7% until 56%. The difference in disease intensity of each soybean variety tested is influenced by plant resistance caused by genetic factors, which have different resistance to stem root disease intensity. In this experiment, the difference in incidence was thought to be caused by the interaction between the resistant traits of each genotype and virulence of the disease. In Table 8, about sensitivity index of several 7 mutant genotypes of soybean and the character of seed weight per plant show that two genotypes have a sensitivity index value smaller than 0.5, which has a character of resistance to stem root disease. For genotype have a value index sensitivity greater than 0.5 and smaller than 1, which has moderate resistant character to stem root disease. And 5 genotypes have sensitivity index value greater than 1, which were sensitive to stem root disease. The tested genotype had an average sensitivity index of 0.99 against stem root disease stress. The range of genotype sensitivity index is 0.05 until 0.11, meaning sensitivity index smaller than 0.5. So, the genotype is resistant to stress from stem root disease. According to Akbar, 2018, a low sensitivity index value indicates that the genotype test under suboptimum conditions didn't show a large decrease, so that it can be said that the genotype was resistant. The research obtained two resistant genotypes with sensitivity index value of 0.25 and 0.05 M100 A25 3/7 and M200 A12 6/5. The lower the sensitivity index value to stem root disease, the better the tolerance to the stress. Based on this, the genotype M100 A25 3/7 has the best resistance. Conclusion. First, the research showed that the appearance of agronomic characters in the genotype in the optimum land was higher than the genotype in the disease-inoculated land. The second, there were 5 genotypes that were sensitive to stem root disease in 7 mutant genotypes of soybean plants. Based on the plant sensitivity index, M100A25 2.7, M200A17 18/5, M200A17 13/6, M300A6 33/8, and M300A8 45/7. The third, there were 2 selected genotypes with high production and resistance of stem root disease character in the 7 mutant genotypes of soybean plants based on the sensitivity index M100A25 3/7 and M200A12 6/5 genotype. Okay, that's all from my presentation. I want to say thank you for the time and opportunity that has been given to me.